Today we are dividing by monomials. In order to divide by a monomial, we will divide the coefficients and subtract the exponents of like bases. In example 1, we have a monomial divided by a monomial. Our coefficients are 48 and 3, and then our variables are x and y. So I have 48x cubed, y to the fifth, divided by 3y squared. So we will divide 48 by 3, and then I don't have an x in the denominator, so x cubed stays, and then y to the 5 minus 2, because we would subtract the exponents of these like bases. 48 divided by 3 is 16, and so then that simplifies to 16x cubed, y cubed. In number 2, this time we have a binomial divided by a monomial, and we will just simply divide each term by 6x. So when dividing, we divide the coefficients and we subtract the exponents of like bases. So when we divide the first term, negative 18 divided by 6 to the x to the 3 minus 1. Keep in mind there's an understood 1 exponent here. And then moving on to the second term divided by 6x, we'll divide the coefficients, 6 divided by 6, and then x to the 2 minus 1. That simplifies to negative 3x squared plus x. 6 divided by 6 is 1. There's an understood 1 coefficient here. 2 minus 1 is 1. There's an understood 1 exponent there. For number 3, we've got 3 terms that are all divided by the monomial 15x squared y cubed. So our setup is divide our coefficients, 45 divided by 15, and we'll have x to the 5 minus 2, y to the 4 minus 3. And then with our second term, it will be negative 15 divided by 15, x to the 4 minus 2, y to the 3 minus 3. And then with our third term, 30 divided by 15, we're going to divide the coefficients, and then x to the 2 minus 2, y to the 5 minus 3. Simplifying that, we would have 3x cubed y minus 2x squared y to the 0 plus 2x to the 0 y squared. And any number to the 0 power equals 1. So rather than saying x squared times 1, we can just simplify that to x squared. And likewise here with this x to the 0, that's just 1. So writing it in our simplest form, we would have 3x cubed y minus x squared plus 2y squared. For number 4, divide our coefficients and keep the base and subtract the exponents with our dividing like bases. 12 divided by negative 3 would give us negative 4. And then subtracting our exponents, we get negative 4a, because 1 minus 1 is 0. So I don't need to write b to the 0 power. I know that's 1. And then a negative divided by a negative is positive. So negative 18 divided by negative 3 gives us positive 6. And then a to the 0 power is just 1. We don't need to write that. And then b to the 2 minus 1 gives us b. So final simplified answer is negative 4a plus 6b. For number 5, set it up where we will divide the coefficients and subtract the exponents on like bases. So we'll have negative 50 divided by negative 10, x to the 4 minus 2, y to the 3 minus 1, plus, and then moving on to your second term and dividing it by negative 10x squared y, we'd have 70 divided by negative 10, x to the 2 minus 2, y to the 5 minus 1. Remember, there's an understood 1 exponent here with the y. And then dividing and subtracting, it simplifies to 5x squared y squared minus 7y to the 4th. For number 6, to take 27c cubed divided by 9c, we divide the coefficients, 27 divided by 9, and then we'll keep the base and subtract the exponents, c to the 3 minus 1. And then taking negative 72c squared divided by 9c, we divide the coefficients, negative 72 divided by 9. Then we keep the base and subtract the exponents, c to the 2 minus 1, plus, with our last term, we'll take 9 divided by 9, and c to the 1 minus 1. 27 divided by 9 gives us 3, and then subtracting the exponents, we get 3c squared. 72 minus 9 gives us, or it's negative 72 minus 9 gives us negative 8. C to the 2 minus 1 simplifies to c, and then 9 divided by 9 is 1, and then we would be getting 0 exponent here, which also equals 1. 1 times 1 is 1. Thank you for watching. Let me